In this video, we'll be talking about strategies for mental addition, and we'll also be justifying those strategies using the properties of addition. Our strategies will fall into two broad categories. The first one will be decomposing numbers into expanded form, and the second category will be breaking apart numbers, not into expanded form, but into other convenient numbers. So let's start with decomposing numbers into expanded form. Recall that with expanded form, we're going to think about place value. So we'll be thinking about numbers in terms of ones, tens, hundreds, and so on. Let's look at an example. Let's add 23 and 16. First, I'm going to talk through my thinking and record it in a way like we might in an elementary classroom, and then we'll formally do this with properties. When I add 23 and 16, I could expand both numbers. I could think of 23 as 20 plus 3, and I could think of 16 as 10 plus 6, and then I could add together the tens, and I could add together the ones. So that would mean I was adding 30 plus 9, which gives me 39. Here, I broke each of my numbers into expanded form and then just grouped liked places. Why am I allowed to do this? Well, let's formally break this apart using our properties. The first thing that we did was we substituted each number for its expanded form. Then, because I no longer wanted to associate the 20 with the 3, I'm going to use the associative property, and I'm going to group together the 3 and the 10. Here I'll put APOA, associative property of addition. Next, I'm going to switch the order of the 10 and 3. I'm allowed to do that using the commutative property of addition. And then now I want to associate the tens together and associate the ones together. That's my associative property again. And finally, I'm just going to add to get my final answer. This is not something that we do with elementary students, but mathematically it shows why we're allowed to use this strategy. Some people call this strategy leading digit or front end. Here I think it's easy just to talk about it as decomposing. Let's add the same two numbers, but this time let's only decompose one of them. So I'm going to decompose the second number. So this is how I might talk about it with elementary school students. Well, if I want to add 23 plus 16, let's decompose the 16 into 10 and 6, and then I can just add 23 plus 10, because adding tens is pretty easy. 23 plus 10 is 33, and then I'll add another 6 to give me 39. We could justify this with properties of addition in a similar way to the last problem. Some people call this strategy break and bridge. To me, it's just easiest to think about this as a decomposition strategy. Now let's talk about strategies based on breaking apart numbers in other ways. One of my favorite mental addition strategies is the make a 10 strategy. Some people call this one compensation. Exactly like the name says, we'll be making tens. If we wanted to add the number 9 and the number 6, we could use the make a 10 strategy. Let's use a 10 frame to understand this. Here we can think about adding 9 objects and 6 objects. When we use the make a 10 strategy, we're going to think about the 6 as 1 plus 5. And then we can move that 1 over with the 9 to make a 10. So we can see that 9 plus 6 is going to be the same as 10 plus 5, and it's easy to add to tens, and so we end up with our answer of 15. Mathematically, why can we do this? Well, let's go ahead and use our properties of addition. 9 plus 6. The first thing we're going to do is we're going to replace the 6 with 1 plus 5. So this is just substitution using addition facts. Next, we want to associate the 9 and the 1 rather than the 1 and the 5. This is our associative property of addition. And finally, we'll just add. So this is a strategy based on the associative property of addition. Let's do some more mental addition by breaking apart numbers. Similar to the make a 10 strategy, the compatible numbers strategy, we just look for convenient numbers that we know how to add. If I want to add 75 and 35, I know my 25s, especially because of working with quarters in money. So let's go ahead and talk through this. Okay, 75 plus 35. Let's break apart 35 into 25 and 10, and then I know how to add 75 and 25 to get 100. Then I just need to add 10 more for a sum of 110. We can justify this just like we did with our make a 10 method. We take our 75 and our 35 and we break apart one of the numbers into 25 and 10 using addition facts. Then we associate the 25 and the 75. So that's our associative property of addition. And then finally, we just add our numbers to get to our sum.